Yes, hello. I'm giving this presentation on the behalf of Harri Haukka, who could not be here this week, and on the behalf of all the other people in consortium also, of course. So, what is LUNINA? LUNINA is a communication in-situ communication navigation node for Moon, and it has several very important properties. It's very compact. As you will see on the next slide, it's quite small, well, this small. And it's independent, meaning that it can operate independently of other systems. So it's autonomous. It's robust. It can have very generic interfaces that can be compatible with many assets. It's also location independent, meaning that it's a box that you can drop basically anywhere on the Moon where there is some sunlight. Of course, there has to be an analysis like how much sunlight do you need, but if you have at least some sunlight, then you can put it there. It's cost effective because it's based mainly on the other systems that have already been preliminary designed, so we don't have to start from scratch. And it's able to operate 24/7 on the Moon. So the LUNINA is supposed to work as communication and data transfer relay for both ground and in-orbit users. And it will also provide a signal for navigation purposes. The platform of LUNINA is based on LINS platform, which we at FMI, together with our partners in Spain, made preliminary specification for mini-pins project that was funded by ESA. And this idea of LUNINA was submitted to ESA in 2022. So I mentioned mini-pins, which is its LINS lunar surface sensor surface package is the basis of LUNINA. I will not go into much details of LINS because there will be another presentation by Ignacio Arruego on Thursday. He will tell more details about LINS. But as you see, it's basically, well, a box that has space and accommodation for different scientific sensors. And in our case, in LUNINA case, the scientific sensors can be replaced with the communication system that we need. So LUNINA, as I said, is based on LINS because LINS concept is very adaptable. And so instead of the scientific sensors, or well, maybe there will be even room for some scientific sensors, but we could also replace them all if needed. The plan is to replace them with Nokia LTE system as the payload. And you have the specifications here on the screen. So it's quite small, but it's scalable. So it can be made larger if needed. The mass of LINS or LUNINA, as we have it now, is about 7 kilos, where around 1 kilo is reserved for the payload, or in this case, for the LTE system. And it is designed to survive on Mars even during lunar night. Oh, sorry, to survive on Moon. I talk so much about Mars that Mars comes into my dreams. It's designed to survive on the Moon, even during the lunar night. And for that, we have several design choices, and I will leave those for Ignacio's talk on Thursday. But one thing I will say, it relies on a European RHU to survive the lunar nights. And for the electric power, it has solar panels, and there's a battery buffer. So really, it is able to operate also during the lunar night. So what could it do? It could form a communication network and navigation aid. So for example, what kind of services it could provide? It could provide exploration support. So there could be communication relay, data relay. It could provide it to ground exploration missions. It could be placed close to habitation and bases. And it could also provide these services to the lunar orbit and transfer from orbit. And the navigation aid could be provided both for the in-orbit assets and also those that are on ground. And there are several deployment locations that we have considered. So this is the Schrödinger crater as an example. And so preferably these boxes should be placed somewhere on high ground and on the crater edges, so they can provide larger coverage for the communication network. But also they could be placed around moon bases or other infrastructure as needed. And once placed there, you can basically just forget about them. They will work for at least 2 years on moon, or they are designed to work at least for 2 years on moon without anyone basically touching them. And as for deployment, the original idea for LINS, or now LUNINA, is to be deployed from a rover. It can be also, the design can be modified so that there will be a standard interface with commercial landers also. And in the longer term, there could be even a dedicated landing system that could bring down not only LUNINA, but maybe also some additional payloads. And that is my last slide. Thank you.